Greetings, Miss Neville Science students. So today we're going to start learning about measuring work and force. Our student learning objective for today is the student will be able to, that's you should be able to determine situations where work is being done and work is not being done. So in order for us to really understand how to measure work and force, we've got to know what in the world work is. So we need to make sure we write down in our notes the question, what is work? We need to make sure that we know that work is a force being exerted over a distance. That word exerted may be new to you. So when you hear me say that word exerted, I'm talking about a push or a pull. Okay? When force is applied or exerted on an object and it moves over a distance, no matter how short that distance is, work is being done. When we look here at this picture, work is being done as she stirs or he stirs that mixture in that bowl. That bowl is moving around, or the spoon is moving around that bowl. And while it's not moving a far distance, it is moving. So work is being done. This little boy pushing his truck, that is work being done. Why? He's moving an object after applying force, after exerting force over a distance. Work is being done in both of these examples. So we want to make sure we're able to identify, in line with our learning objective, examples and non-examples of work. I want you in your notes, please, to write the words examples/non-examples of work. And I want you to make two different lists, like Miss Neville's done on her screen, kind of. On one side of your list, you need to say work. And on the other side of the list, it needs to say no work or not working. I want you to write down some examples of work being done in our real world around us. Stirring in a bowl, pushing a toy across the floor, throwing a rock. You want to write down at least 5 examples of work in the real world. Then I want you to write down some examples of work not being done. Miss Neville gave you your first example that you can write down on that list. A man pushing against a wall. No matter how hard he pushes, and you can see in his face, he is pushing, he is applying some sort of force, but it's not moving over a distance. That wall's not budging, so work isn't being done. I'd like you to write down 3 real-world examples of where work is not done. So we can make work easier. How? Please write these down. There exist machines or tools that can be used to make the amount of work that someone does easier or more efficient. Whenever I see that word efficient, I want to make sure I know that that's just another word, yes, a synonym for easier. We also want to make sure we know that these machines make work easier by either decreasing, that means making you travel a shorter distance, or making you reduce the amount of force you have to put in to move an object. So that's the purpose of machines in making your work easier. So these machines that we're going to start talking about in our next recorded lesson are inclined planes, levers, and pulleys. If you would please write in your notes and draw these pictures, simple machines. And there are 3 that we're going to focus on as 6th grade scientists this year. The inclined plane, please draw that picture. We know of an inclined plane as a ramp. You've seen plenty of ramps. Movers have ramps. Okay, you probably made ramps before with toys you had when you were younger. Okay, levers. The easiest way to think of a lever is a seesaw. We're going to learn about all different types of examples of levers, but the seesaw is another great example of it. And pulleys. So when we're looking at these three examples, it's important for us to understand that these three simple machines help to make work easier. I hope you've enjoyed this lesson. Please watch it over or pause it anywhere you need to and have these notes ready to go on Wednesday for our first day of class. Bye.